What up everyone, this is LeetCode 110, balanced binary tree. I've solved this problem in Python, but now we're doing the C++ implementation, so we're given a binary tree and we have to determine if it's height balanced. And the tree is height balanced if the depth of the two subtrees of every node never differs by more than one. So the depth of the two subtrees can differ by one, that's fine, it just can't be more than one. For example, here, at this tree, go to the left subtree, the height is 1, right? And on the right subtree, that's 1, 2, right? 2 minus 1 is 1. So the height difference here is 1, which is fine because it's not more than 1. So this is balancing, we return true. Here, for example, though in example 2, go to the right subtree, the depth is 1. On the left subtree, though, the depth is 1, 2, 3. 3 minus 1 is 2. So it's not height balanced because the depth differs by more than 1, right? It differs by 2 in this case. So this would be not balanced and we return false. Okay. Now, right off the bat, right, for this problem, we need to handle an edge case because we can have a case where we have 0 nodes in the tree. And in this problem, if you have no nodes, as you're basically just given an empty tree, technically it's considered balanced, okay? So we're going to just say if root is equal to null, right, just return true. Okay. Now we need to basically handle this problem recursively. Okay, so I'll explain our approach here. Okay, gonna have a DFS function. So the way we're gonna handle this problem is we're basically gonna go all the way down to the bottom of the tree, right? And we're gonna work our way up, right? And so when we go up, we add 1 to the height, right? Because we're going up 1 level, right? And when we're here, we look down to the left and we look down to the right, and we take the max height here. In these cases, it would be 1 either way, right? So we get 1, which is the max height, and we go up and we add 1 to the max height, so it'd be 2. When we're at this node, it's 2, right, for the left subtree, which makes sense, right? Because the max height is 2. Then we basically take the max height from this 2. We take the max. Instead of height, maybe I should say depth, which, I mean, whatever one is easier for you to understand, same concept. But when we're at this 2, we take the max height or the max depth from the left subtree and the right subtree. Obviously, the left subtree has a depth of 2 and the right subtree has a depth of 1. So 2 is the bigger number. So we take 2 and we add 1 to that when we go up. So when we hit this 1, the max depth is 3 for the left subtree, which makes sense, right? Because we go 1, 2, 3, right? That's what we should expect. So when we get to this 1, and by the way, every time we go up a level and we're basically before we add to the depth, we're checking, is the left subtree and the right subtree balanced? Meaning, if we take the depth of the left subtree minus the right subtree, is that we take the absolute value in case we do 1 minus 2 or 2 minus 1, it doesn't matter. Because if we do 2, let's say we do 3 minus 2, right, that should give us 1. If we do 2 minus 3, though, then we get negative 1. So we when we're at a specific node, we take the absolute value of the left subtree depth, the max left subtree depth, and the right max subtree depth, and we basically do left minus right, take the absolute value of that. And if that number is greater than 1, that means we have an unbalanced tree. So we can just basically send that a negative 1 up top. Instead of adding 1 to the height, we just add negative 1. We just return negative 1 when we go up. So by the time we get to the root node, if we return negative 1, we know somewhere in our tree we became unbalanced. Okay, so we can return false automatically. Okay, so if root is null, return 0. Okay. And I'll go through the example as we go along, okay? Or after I write our code. Okay. Int right is DFS root right. Int balanced. What's the value of left minus right? Right. And here, basically, if we have -1, right, then we return 1 plus the max of the left and the right subtree. Okay, so this is basically all we're doing. So I'm going to explain this, okay? So basically, we start at this root node, right? And we're going to go all the way down, right? Now, when we're at this 4, we go left and we go right. And the root is going to be null, so we just return 0, okay? Okay, so we return 0. Because we went left and right and we return 0. So we do left minus right. The absolute value of 0 minus 0 is just 0, right? So we aren't going to enter this if statement. So we're just going to go left. We're going to return 1 plus the max of the left and the right. Well, the left and the right here is just 0. Obviously, there are no child nodes. There are no child nodes. So we just do basically 1 plus 0. So when we go up to this 3, right, we're at this 3. We basically check the left and the right, right? So it'd be 1 and 1, right? Well, technically we're doing the DFS here, and then also basically the same concept of checking the child node 0, 0. We add 1 plus 0. So at this 3, the left and the right have a height of 1. So right at this 3, we would do 1 minus 1, which would be 0 again, right? So we would do 1 plus it'd be 0 when we do the absolute value of left minus right. But when we return 1 plus the left and the right, it doesn't matter. We're going to return 1 because the left and the right are equal, right? So the max is just going to be 1 in either case. So we add 1 plus 1. When we go up, we pass that up to the 2, which makes sense, right? The height is 2 so far. Now we're at this 2, right? And we do the DFS here, by the way, as well, right? We go up. So at this 2, the right subtree should be 1 for the depth, the max depth. At this 2, the left subtree the max depth should be 2 for the left subtree. Okay. So at this 2, the left is going to be 2, the right is going to be 1. 2 minus 1 is 1, right? That's balance. Is balance greater than 1? No, balance is equal to 1, right? Because it differs by the height by 1, not by 2, or not by greater than 1. So we don't enter this if statement yet. Now we return 1 plus the max of the left and the right. Well, the right is 1 and the left is 2, so we do 1 plus 2. And we pass the 3, which would be 1 plus 2, it'd be 3. We pass that up to the 1, which makes sense, right? Because we 1, 2, 3. So the max height should be 3, so algorithm is working fine. Now, when we're at this 1, the left subtree height, the max depth, is 3 on the left and only 1 on the right. Okay, so we're going to say imbalanced. Left minus right is 3 minus 1, so we'd get 2 for balanced. Is 2 greater than 1? Yes, it is. So we return -1. Okay, we're not even returning this, we just return -1. So because we return -1 rather than a positive integer, we know we have a problem and we should be returning false, right? So down here is where we're going to check that. So we're basically going to return DFS root not equal to -1. So basically what this is going to do is it's going to return true if we are not returning -1, returns false if we return a -1, which is what we expect, right? Because if it's not balanced, we should return false, and that's what happens here. This might be a little bit confusing, right? So technically you can write this as like, I mean, you can do like a longer format code if it, I don't know, it's easier for you to understand or whatever. You can just say, you can say index is equal to DFS root, and you can just say if x is equal to -1, right, return false. Else return true. Right? I'm not going to do that though. I think it's just a little bit simpler to just write it like this on one line. But yeah. So we're basically just going all the way down. And when we go up a level, we add 1 plus the max of the left and the right subtree for that given node that we're on. So yeah, I walked you through example 2. So I think you should understand. It's not terribly complicated. You're basically just working bottom up. That's how you're approaching this problem. But yeah, I hope this helped, and I'll see you in the next one. Oh, and by the way, the reason we have left and or right equals to -1 is because let's say the tree became unbalanced somewhere here. We pass -1 up, so when we get this 1, right? If the left is -1, we just return -1 at the root. So the reason we pass -1, we have left is equal to -1 or right is equal to -1, is we're basically just checking, okay, if the left subtree, when we hit this root, if the left or the right subtree is -1 because it gets passed up, -1 is really like, think of it like a flag, right? If we check the left subtree or the right subtree and it's -1 for some reason, it means that at some point this tree became unbalanced. It just kind of flags think of it like a flag, really. That's all it is. So yeah. Anyways, I hope this helped, and I will see you in the next one.